of construction do not get in the way. They're tearing down one of the streets and buildings nearby, so hopefully it's not too obnoxious. Construction do not get in the way. They're tearing down one of the
Seems to be
streets
good.
and buildings.
So, welcome back, Internet. This is our Asteroid virtual reality game that we were making. Well, it wasn't really supposed to be an Asteroid virtual reality game. It was going to be a puzzle game, and we can fly around. I don't have the headset on, obviously, so it's hard to see, but you can use these to fly around. And then you can look around because it's virtual reality and do whatever the heck you want. All of these buildings are, I think, 50 meters high. Posted a video yesterday where I ran into one of them. That was fun. Yeah, so this is what we have after day one. We have VR stuff. We also have this menu, which we may be recycling. And what we're going to do is we are going to drop you in space. And once you're there, we're going to have you kind of fly around and land on asteroids and then plant a bomb on them to blow them up. So it'll be like asteroids, but instead of having like a ship with guns, you're going to actually be able to shoot them. So I don't really know how this is going to work. I have a feeling it's going to result in massive motion sickness, but at the same time, I have a feeling it's going to be cool. So we're going to see where it goes and figure it out, I guess. So hopefully it goes better than I'm anticipating it will. But to figure this out first, let's delete that guy. And we can delete this world manager as well. And then I'm going to drop in just some shapes for some testing. So let's do one there, I guess. So all I want is some cubes that we can stand on, and then I'm going to rotate them funkily. And apparently can't, didn't actually create the cube. That would be important. Okay, so we have this guy we can stand on. Gonna just make it a little bit bigger. Sure. Doesn't need to be precise, we just need somewhere to stand. But then I'm gonna bring it down as well. And then we're gonna copy this a few times. Whoa. Then we're gonna copy it. I already had it copied, but I only grabbed the bottom apparently. And then we're gonna stick this here, and then I'm gonna rotate it just a little bit. And so the trick we're gonna have is our asteroids can rotate. And they're going to be smashing into one another, and you're going to be landing on them. And hopefully the idea is there's going to be gravity fields in this as well. So you'll rotate to actually land on these things face down. So the entire player is going to rotate, which is probably going to end poorly for everybody. But I have a feeling it's also going to be really fun. So we've got 2 now. I'm going to add let's keep it at 2. So what we want is these to actually be asteroids. We want them to have a center of gravity. And so to make sure you kind of land feet down on it, how this is going to work is we are going to, I think the best way to do this is to drop in we're going to have to remove gravity for one. So this guy can no longer use gravity, which for now is going to be terrible because you're going to be able to fly off. And then we're going to have to detect the distance between the two. And then based on that, we're going to have to orient you towards one or the other. And we're probably going to have to do quite a bit to make that work correctly. But for now, I think that will work. I'm going to actually drop, I had added a bunch of other packs that I was going to play with. I had like one of the Dark City packs from K4, their model maker. some birds and stuff, and I was just kind of playing around with it. It ran poorly, really poorly, honestly, and that's probably because I just dropped in like a massive demo scene with like fog and massive amounts of particles and like hundreds of buildings, and it didn't really work. So I'm gonna drop those and crash Unity. And now that that's done, we can go in here. We want our, how do we want to do this? Let's go and create like a gravity folder, I think that makes sense. And then from that, we can do a, what do we want to call something that emits gravity? Gravity well? I guess we could just call it a gravity emitter. That works. And so, how do we want to do this? So gravity is based off of the mass of an object and the distance from that object. So as a rigid body gets heavier and heavier, it's going to emit more. As it gets denser and denser, it's going to emit a heavier gravity. So that's why, like, Jupiter, for example, is going to, well, no, not Jupiter. That doesn't make any sense. But if you have like lead, for example, that is much denser than, say, helium. I don't know what I'm picking. Anyway, it's going to be denser. So since it's denser, it's going to have a thicker magnetism about it. So how we can do this is our asteroids, the bigger ones, are going to have higher mass. And because they have higher mass, that's going to mean that they can, well, emit more gravity. So we're going to need to come up with some sort of formula based off of the mass of our asteroids to generate the gravity. So right now we don't have any because I turned it off. And we're going to have to actually, we could keep gravity on and then constantly manipulate it so that it was always pulling like towards whichever and solve for that. I think the best way is just to attach some other thing onto this camera rig, and then based on that we'll apply some force that is the net sum of all of the nearby gravity. And we may have to drop the realism a little bit, because I think if we just keep it too real, we're probably going to run into issues. Because if I feel like if we just do gravity normally, it's probably going to get super confusing. So we'll see where that goes. We aren't going to need any of this stuff, really. Let's see, gravity emitter. Let's make this require component of rigid body. So you need to plug in a rigid body here, and then that rigid body is going to emit some sort of gravity. Okay, how do we... I should look up the formula for gravity quick. Let's just... I have a different browser open, but I don't want to have that display all of that stuff. So let's do gravity formula. That's not how you spell formula. So it's going to be the gravitational constant times both of the masses divided by the distance. So r squared is going to be the distance between the two objects. G is the gravitational constant, and m1 and m2 are the two masses of the object. So that's going to be our player, and it's going to be whatever our asteroid is. Yeah, I think that makes sense. So, and then that should result in a force going towards whichever thing we need. Yeah, so this will result in some sort of scalar value. It's going to result in some sort of floating point number, and then we can calculate the direction between the two, the difference between the two vectors, and that will be the normalized vector of that times this force value will give us a force of gravity. I think that makes sense. Okay, but for now, let's just do this the super easy way, and let's not do anything. So we're actually taking everything out of here. We're not going to do anything. The only thing we're going to do is attach this gravity emitter to both of these. And because it requires a rigid body, it's going to stick a rigid body on there. I'm going to make these kinematic. So when you land on them, since you are a rigid body as well, we don't want the asteroid to float away as well. That actually may be pretty cool. And maybe we'll add that back in, but for now, I don't really want that to happen. It'll just make debugging all of this way harder. So we have a rigid body with nothing on it. And now, what we want to happen is so what I'm thinking is we were going to cast a ray towards whichever object is nearby us. So since the player's right here, I'd cast a ray straight down into this, and then we'd calculate the normal from the plane that you hit, because you're going to hit this mesh somewhere, and then that's going to be the up vector that we want the player to have. And so if you fly over here, you'd hit like this wall, and so you'd have a vector coming off this way. Does that actually? Yeah, going off this way. And so it'd come off, and that would be the way you'd look. And so theoretically that will let you do gravity, I think. It may look a little bit weird, but we're going to do that anyway. Okay, let's do it. Player gravity controller. All right, so this guy is going to handle orienting the player. And so right now I'm thinking all of this orientation is going to happen automatically. We probably are going to have some extra room on here that we could actually probably use these for like yaw, pitch, and roll. Well, I guess yaw is already handled by turning your head, but we could handle this by like roll and pitch, and that might give us something. I don't know how good that'll work, but we may be able to use that instead, so you can rotate in 3 dimensions. We'll have to play around with it. I honestly have no idea. So, what else? Player gravity controller. He is going to find the... Let's get a list of all the gravity emitters. So we want an enumerable of gravity emitter. And so I'm just using IEnumerable here because all we're going to do is loop over it and find the nearest one. So IEnumerable of gravity emitter. Gravity emitters, we can call it that, sure. Get rid of that underscore, it's not needed. And let's add a reference to this type from our collections. Okay. So we have our gravity emitters. They're going to do something. We need to initialize them. So gravity emitters equals find we need to close this and reopen it because it was loaded in it wasn't part of our solution, so IntelliSense wasn't going to work. Find object of type. Let's find objects of type. Gravity emitter. That's going to return, I think, an array, which is enumerable. So enumerable, the only thing that this like enumerable interface does is it's going to allow us to get an enumerator. And all that lets us do is enumerate over things, for example, in like a for each statement, which is exactly what we're going to do. So for each emitter in our gravity well emitters, we want to find the nearest one. So I'm going to save the distance, and that's going to be initialized to the max value. And the reason I'm doing this is it's going to make our logic way easier. Since this is set to the max value, everything else is going to have a distance less than this, so it'll automatically replace it. And then we can save the nearest emitter. And this can just be null for now. So if the magnitude of the emitter position and this position is less than the distance, then we want to set the nearest emitter equal to the current one. And we're also going to want to write this out to a variable. And the reason we're going to want to do that, emitter range, I guess we'll call it. But the reason we want to do this is because we're going to use it twice. We're going to use it here, and we're also going to set it in the distance. And this prevents us from calculating that value twice. So now that we've done this, assuming that the nearest emitter is not null, we should be able to find, well, we should be able to find our proper emitter, or we should be able to orient our player. And so how we're going to do that is we're going to create a ray, and I think we can just cast it towards the center of the asteroid, and that should hit something. I mean, actually, it's gonna have a rigid body attached, and those have a center of mass, so we can probably cast it towards there. I'm not going to. Well, yeah, let's do that. That'll be smart. So equals a new ray, and we want the origin to be this origin from our current position, and we want to cast it towards the nearest emitter position. So we're going to subtract the nearest emitter's position from our own position and get the difference between the two, and it should point towards that new position, or it should point towards that new target. So I think that's all we need there. That's going to create a ray. We want to get the raycast hit, and we're not going to do anything with that yet. And then we want to raycast our ray at the maximum distance we can towards whatever, and let's out our hit value. And it doesn't like this because I always get those out of order. Okay, so this is going to return true if we hit something, and if we do, it's going to set this hit value to our raycast hit. So this is something that you can only do in C#. That if you've used like Java and you think Java and C# are pretty much the same, just with a slightly tweaked syntax, this is something you won't be able to do in Java. And what it's going to let you do is it's going to actually allow you to change the references. So Java is all pass by value. When you pass an object, you're actually passing the value of the reference to that object. What this lets you do is it lets you pass that actual reference to the object. And so we can this is actually going to change that reference. So we're actually changing which variable we're pointing at. And because of that, we can actually get more information out of our functions than just returning true or false. So it's kind of handy. It can get confusing sometimes if people don't understand it or don't think about how they're adding it into their APIs, because it can make things really confusing, but it's a pretty fun feature. Okay, so now that we know we hit something, we can calculate the direction we want to face. And that's going to be our target up vector. And so this target up vector is going to be equal to our hit dot normal. I don't think The normal of the surface the ray hit. Yeah, that's what we want. So this should get us the normal that we want. And for now, I'm going to regret doing this, but I'm going to immediately set the rotation so that quaternion dot we want to immediately set it so that it's looking at whichever, so that up vector is our up vector. So look rotation, I think that should work. And so yeah, I think this, we can make this work. So the look rotation is going to be this, and we want it to be, it's going to ask for a forward and an up vector. We want to give the forward vector as our current forward vector and the up vector as the target up vector. And I don't think this is going to work, but we're going to try it anyway. Okay, so what this function is going to do is this code is going to find the distance to the nearest emitter, and it's going to return the nearest emitter. Once we have that, we're going to cast a ray towards the center of that nearest emitter, and if we hit something, then we're going to rotate our player to have the up vector equal to the normal vector of the surface we hit. So theoretically, nothing should change initially. It should just be normal. And if I did this wrong, we're gonna, no. It's probably gonna freak out if I did this wrong, but okay, it seems to be working. Let me turn these on, and then I want to fly over there. Okay, so it seems to work. All right, so that was too fast, way too fast. But what we can do is we know our current rotation and we know which rotation we need. So I'm going to save this quaternion as our target rotation. And so a quaternion is a 4-dimensional vector. And the reason you do that is it avoids something called gimbal locking, and it also lets you animate in 3 dimensions smoothly. You get you'd have to look it up, but there's some weird things that can happen. Gimbal locking is probably the most common, and that's when 2 of your axes overlap. So if you've seen like the 3 intertwined circles of X, Y, and Z rotations, if you do like 90 degrees of that, like say you look straight up on your camera, suddenly 2 of your axes are perfectly aligned with one another. And so when that happens, then you can flip your camera upside down and invert everything, and it just gets weird. So quaternions help you solve that. So when you were working in 3D space, we usually use them to help with the rotations. So now that we have our current rotation, or the target rotation, let's take the where we're trying to get, and let's lerp from our target, from our transform rotation to our target rotation at the time dot delta time. So this is going to slowly rotate us towards it. It isn't going to be perfect. This script is still not going to work perfectly, but what it's going to do is it's going to even out that rotation towards wherever we were. So it will actually pull us towards our object. Yeah, I think that makes sense. Okay, so we have our standard guy. Ooh. Sorry, smacked you in the face. Well, so we're getting totally lost here. And the reason that's happening is because there's no gravity. We can see though it is rotating to face those directions, which is good. We'll probably want to have some sort of function that's going to determine that lerp value, so it will happen faster or slower depending on like how close to an object you get. We'll have to come up with how to do that better, but for now I think that's probably fine. It's not fine, but it's fine. For the player gravity controller, let's actually add some gravity. So let's require a rigid body, and we'll assign it. And we have to declare this as new because there's that old rigid body type. And let's get our rigid body like so. And now we can actually, now that we have the normal, that's going to be the up vector. If we take that and reverse it, if we take the inverse of that normal, that can be the gravity that will pull us towards this object. So what we can do is we can take the target, we can take the rigid body, and we can add force equal to the negative target up vector. And we can multiply that by 9.8. And that is in meters per second, the amount of gravity that is on Earth. That's just for quick use. We'll have to actually calculate this because asteroids are going to have their own gravity. But for now, we can just use Earth's. And then we need to, since it's meters per second, we need to multiply that by our time delta. And this should actually apply our force down. So this should apply gravity to the player. Now, we should be able to sit there, and I'm going to slowly kick us towards that other thing. It's being a little bit slow, but okay, kind of rotating. Oops, my bad. Oh, this is so awkward. Okay, so something's happening. I don't really know what, but oh. Okay, so what's happening is our player is not aligned with the asteroid. So the player themselves is sitting over here, but the actual object is not. Okay. Huh. This is going to require some actual like hard 3D maths. And the reason that's going to be required is we need to keep the play space as oriented as possible, or as near as possible as we can, to being to only rotate. Like if I drag this over here and down here, we want it to rotate like this. We want that to happen. But it could happen where that happens, or where something like some other rotation can happen. Not that, but like something like this can happen where the player rotates like that, and suddenly what should have been forward was actually a forward with a right twist. And that's just all kinds of wrong. So we need to stop that from happening. And I don't really know how we're going to do that, but I'm sure there's a way. I mean, other people have solved this problem, right? So there's got to be a way. Not that I'm going to look it up, but we can figure it out. So the good news is it does appear that we're actually rotating to face things. The bad news is our player is not staying in the center, and our calculations are all centered here. So if our player moves from that center, all of our calculations are off. So I think we need to probably change our positions, like this, that transformed up position. All of those need to be changed to use the player's position. Their actual position, not the position we're kind of making up for them. And I think that should solve that problem. What else? This is just going to get confusing, isn't it? Whatever, that's fine. So we have this guy. What is going to give us where our player is? We have thrusters, collider controller. I think the collider controller can be used to give us our position that we want to do our calculations from. So let's use that. Actually, let's use the capsule collider. We can actually, from our rigid body, I think we can get this collider, and that should be able to get us the center of mass. And from that, I think that'll give us much better calculations. Dot center of mass. We'll use the world position center of mass. That makes way more sense, since we're doing all of these calculations in world positions, or world coordinates anyway. So if I change all of this to be the world center of mass, it should make a little bit more sense. So now we're not casting our ray from the bottom of our point, we're casting it from where the player is. Cool, glad you like it, Pure Play. Yeah, that's kind of why I make them. So if there's anything you want to see, let me know, and I'll do my best. But all right, getting back to this, we've got our world center of mass, and we want to make sure this works. So let's see where this goes. This is probably going to end poorly, but if we jump over here, kind of, no, okay, that's not working at all. So, well, good news is we're flying off this way. Bad news is that's not what we wanted to happen. Okay, come back. I'm just gonna slam this person, the player, into a wall quick, and that should stop their momentum. Hopefully it fixes some things. Okay. One sec. Smack. Okay. So our player is hitting that. The good news is it looks like our ray casts are happening correctly. Bad news is our player isn't facing up. So so now we have whatever this is, and yeah, don't really know how we're gonna fix this. This is all kinds of wrong. So we need to get this to face up. And don't worry about distracting me. I'm just fooling around right now. So, I mean, yeah, the reason I do these is because it's fun to interact with people that actually either make games or play games or make apps or whatever. So if there's something that you want to talk about, we can do that. That's why I'm here. So let me know. Anyway, we have to do rotation math. Lots of rotation math. How are we going to do rotation math? The issue is not here. This is correct. This is not correct. So we need to find some way to rotate towards our position. And so that position is going to be, how are we going to do this? We want to rotate towards this up vector with our forward vector being as little change as possible. So we want as little change as we can. This is when I wish I would have paid more attention to my graphics classes. but maybe I did remember how to do this and I just don't remember right now. But there's some way you can do this to get it to face the direction you need, but I don't know how to do that. So, well, actually, I think what we can do is we can take our I think we might be able to use cross products here. So the look rotation should still work, but I'm going to use the target up vector, and then I'm going to use the cross product of our player's right position, and we're going to use the target up vector. And so what a cross product does is if there's an up, if you have two vectors, so the classic like 3D thing, I forget which way it is for OpenGL and DirectX. One of them is this way and one of them is this way. But you have the three vectors, you have up, forward, and left or right. And so if you have two of these and you plug them into the cross product, you'll get the other one. Which one you'll get, whether it's left or right, is going to depend on which type of it's different for DirectX and OpenGL. One will give you one way and one will give you the other way. And I don't remember which one is which, so we'll have to figure that out. But I think this should give us, if we take the right and the up, we should be able to get the forward of this. And it should keep us relatively oriented. I think that makes sense. So I started making videos like 2 months ago, and it's kind of just been something I've wanted to do for like a few years now, and I never had the time. And now that I'm out of school, I can kind of play around with it a lot more. And frankly, this is super fun. If you make videos, or if you enjoy just making things, this is a really fun way to explore that. Actually, I think we may have solved it. So this guy seems to be working. I don't know if it is or not, but I think it is. We want to actually probably increase our gravity, but I'm gonna smack into this. And I think that's got us pretty close to what we want. It seems to do mostly what we have, so PurePlay, you're about probably a year behind me. I graduated in January this year, so I've been out of school for 8-9 months now. So it's been interesting. It's been a change of pace, which is good and bad, but it's been fun. So let's see. I think this actually is working. I think we can move on. I don't want to say that and then have it not work, but it seems like we have a way to actually do orientation, and it seems to all be working. So I think I'm going to call that good. I think we're going to pretend like that's actually how we want it to work. And if it isn't, I'll get motion sick and everything will go horribly wrong. So everyone else on their tutorials, and I'm sharing my knowledge. That's kind of what I'm trying to do here. When I started this, I kind of wanted to I see a lot of tutorial videos, and I kind of wanted to make my channel a little bit different. I want to sort of explore failure, I think. So if you watch some of my other videos, I don't have a script, and it's usually something I've never done before. And so it kind of gives me an excuse to try something new like this. I have never done, until yesterday, I hadn't really developed for VR before. So this is kind of a way for me to screw around and still get some feedback. And also, I think learning is best done there's a good way to fail, I guess. And so I think I fail relatively well. And so because of that, I think, or I hope people are learning from it. I think that's what I'm trying to get here. So we can fly between asteroids. Now, I think what we can do I think we can make a move, which is going to be a whole other mess. But before we do that, I want to actually parent our player to these objects. So we have our gravity controller. And what I'm going to do now is I'm going to attach to on collision enter. And then in on collision exit, collider. I think this is how you do this. And so what these are going to do is when we enter a collision and when we exit a collision, I want to attach and detach my parent from them. So yeah, VR is awesome. It is awesome, especially developing for it. So yeah, if you can play with it, definitely do. It's expensive to get into, but at least my thought was with what the games are going for right now, if I can make even one that actually kind of sells, then I feel like it'll be paid for. And frankly, this is the most fun I've had developing a game in a while. I do a lot of like game jams and just kind of fooling around, but this has been a ton of fun to play around with. So I'm really enjoying it so far. All right. So when we enter a collision, let's set the transform parent equal to the collider.transform. And then when we exit one, let's just remove that. And so assuming we do this, we should be able to attach. We're gonna have to give it just a little bit of power. No, still not working. Why not? Huh. Maybe that's not how you type that. Is that the wrong function? It could be. I always get those mixed up. On collision enter. I mean, there'll be a video on demand too if you want to work on your own thing and then come back. That's up to you. I wouldn't mind. Well, kind of mind, but you do you. And yeah, thanks for watching. All right, collider should do this. I'm gonna stick in some breakpoints here and then attach to Unity, and hopefully we can debug this and see what's going on. Or we can just wait. All right. Oh, that's the problem. This has to be of a different type. You need this, that you use a collider and when you're using a trigger, but you use a collision when you're testing for a collision. That kind of makes sense because it's in the name. But anyway, I always forget that. Now I remember. So now we should be attached, and we are. So I should be able to move up, and I should be able to fly into this guy. Oh, that's so weird. Oh, I'm so gonna get motion sick from this. All right. Our gravity is really weak. It feels like it should be stronger than it is. Because we're just kind of flying off into wherever it is. Yeah, I realize you can do a collider on trigger. I'm just it's been a long week. Done a lot of weird things today. It's been fun though. Been doing a lot of interesting things. So, all right. I'm going to up the gravity because it feels really weak for some reason. So 98.1 meters per second. It still feels weird. I thought it would be stronger than that, but it isn't. So now we should be able to get here and should land Oh, I think we went into orbit. Okay. Yep, so we are now orbiting an asteroid. Oh, geez. Oh, this is good. We need to stop this. This is madness. All right. So let's not do that. This should get us to this. Nope. Nope. Okay, fine. Am I applying those forces right? It looks like I may not be. I'm starting to think those may be local positions. Because it shouldn't have gone over there. I'm gonna check some things quick. We've got our target rotation equal to that. We're adding our force. Is this in world position, world coordinates, or is this in... It is in world coordinates, so that is correct. I think we're just entering orbit around an object. Oops. Let's make this bigger then. That should solve this. There. Okay. Now I should be able to hit it. There. And now we attach to this. And now that we're attached, if I rotate it, it will rotate as well. The only issue we're running into, the reason this isn't working, is because it's set to static. So I can fix that too. So we need to make these not static, and that should fix that. Things with physics are sometimes kind of weird. You can say that again. All right. So I think we need to rotate our asteroids. That's our next step. And this is gonna be a terrible idea, but it's fine. What could go wrong? Gravity. Let's create a what do we want to call it? A rotation force adder. That sounds like a terrible name, but that's fine. So we've got our rigid body. Oh, that's not how you do that. We want to require a rigid body. That's not how you do that either. Whatever. I'll just type everything wrong. Okay. So we've got the rigid body. And this is going to be our that. My naming conventions are very weird. I don't really have naming conventions. It's kind of whatever I feel like at the moment, which is why my names are all terrible. Yeah, it's kind of become a running thing where I name something and it's always bad, and then I get annoyed at it and change it later. But I don't know, something to work on. We've got our float. We can do, what do we want? Our max rotation force. And I'll set this to like 100. And so this is just going to apply some force, and then it's going to apply some force, some torque, I guess, to the rigid body, and then it's just going to delete itself. So we can add some torque on a random sphere with our max rotation force, and we can do this actually inside the unit sphere. And so this will give us anything between 0 or 1 in a vector, and then we can multiply that by our force, and that should give us some sort of rotation on our objects. Next, we should be able to just destroy this script. And so the script will just run once and then it will go away. That's fine. That's all we needed to do. So let's drop this guy here and see what happens. Probably something terrible. This isn't going to do anything because our objects are kinematic. So I'm going to increase the mass on these significantly because they are now going to move when you collide with them. Okay, that didn't work as I planned. I think we just never collided with it. Yeah, I made that way too high. Let's get rid of our angular drag so it doesn't slow down at all. But, oh, that was angular drag on our player. That we don't care about that. We do care about it on this. And then I'm going to reduce that rotation force by a lot because that was too much. And then we get this, which is almost nothing. Let's actually pop him up a little bit. Okay. Why isn't it moving? Mesh collider with non-kinematic rigid body is no longer supported. Okay, that's what's going on. Got it. So we can change these to box colliders here. And there we go. Now it should work. So we've collided this time. I'm going to actually, now that we've fixed that, I'm going to kick this up again. And now the issue is I don't know if it's not getting any force or if it's just not rotating. Because I kind of want things to just kind of happen generically. I don't want to set the force constantly because these are eventually going to run into one another and go off and do their own crazy thing. But I do want them to move a little bit at first. And it doesn't appear to be doing that. I mean, it is rotating. We can see it rotating slowly. But I'd prefer something a little bit bigger. Whatever. I have a better way to do this. Let's go crazy. Plug in big values. Bigger values, I guess. Alright, yeah. We're going to go with your suggestion and just log it to the console. Because I imagine I just made it way too heavy. And so that force is just not doing anything. Like if I reduce its mass, it starts going pretty well. So I think it's just the asteroid is too heavy for its force. And we just launched our player off into... I didn't think that was going to be possible. That's kind of scary. Awesome, but scary. So our player can be launched off of asteroids if it's moving too fast. Okay. We'll pretend like that was intended. That's pretty cool. Okay, you can slow down anytime now. Whatever. There. And then we land and go flying off again. Oh. All right, this is going to get messy really quick. I can just see it happening because all sorts of weird things are happening now. Okay. So we're just using like a constant gravity now. I'm not sure we want to do that, but we'll get to that later. For now, let's add more asteroids, I think, and make them move. And then when we can, how do we want to do this? I'm thinking like the game field and normal asteroids is sort of like a box. And then the box kind of rotates so you can go off one side and come in on the other. I don't know how that works, and I don't know how we can make that work in VR. I don't think we can. So what we'll probably end up doing is, I think what I want to do is I want to have like some sort of planet or something in the middle, and then have this be rings, like one of the rings around the outside. And so there will just be a bunch of asteroids that you can go to, and they'll all be kind of clumped and just kind of rotate around the planet. And that way the entire world kind of changes as you move, because you'll just be rotating around a planet. And so to do that, it's actually probably going to be pretty easy, because we can just drop in some sphere and just make it huge, and then just rotate things around it. And I've already made a planet texture generator a long time ago, and something that went a planet shader too. So I think that's already kind of done, but I don't know if we want to use that or come up with something else. Now I don't even know if we want the planet at all. For now, I'm using OBS for recording, so it looks something like, my setup looks like this. Anyway, we have this. Well, let's add a few more asteroids just because. And since the rotation now is random, we don't really need to rotate them at all. You can just drop them around. And now, let's see where this goes. So everything is rotating. I'm going to actually drop their mass just a tiny bit. So we'll make them weigh 1,000, whatever that is. And now we should get something. And so if we look up, we've still got that, but I can kind of play around with this. Okay, yeah, I can see somebody getting super sick from this already. That's fine. Oh well. So they are somewhere, probably way up there. So I think we're seeing the biggest problem that we're going to run into. That's going to be figuring out where the heck you are. I would be totally lost if I was playing right now. So I think what we can do is run and try to do some, let's probably bring in some like stars and stuff and make this a little bit easier to navigate. Yeah, so we are going to do some random generation for the levels. I don't know how that's going to happen, but we are going to have some sort of random gen. We're going to have to come up with something cool for that, but don't know how it's going to work. I don't really know how anything's going to work. But yes, we're definitely not just going to hand place them. That's too much work. I want to be able to just say, make a level with this and have it go. But now we need to figure out a way to make them less crazy. Like I want it to feel like chaos, but I don't want it to feel like you have no control. And maybe we fix that by just making the asteroids bigger. Because right now they're about the size of a small room. And that's pretty, like, it's big for asteroids, I guess, but it's pretty small for a play space. So if we make them bigger, that might make things easier. Or it might not. Huh. We'll have to figure that out. For now, I don't know what we want to do. I had all these thoughts and then they're all gone. That's fine. We'll figure something out. We've got this. We've got our gravity. I don't want the asteroids to be affected by gravity. We were going to make stars. That was what we were going to do. And so we have our directional light somewhere. I lost it. It's up there. Okay. So we've got this guy. And that's our light. That's going to be our sun, I guess. But we need We need stars. We don't really have stars. I think we can actually open this up, create a new, how big do we want it? 2048 by 2048? Or 4K? Let's do 4K. So we have a giant black square. And now, let's see if we can stick some other stuff in here. If I add a white layer, do I want to do that? Not really, but that's fine. We can add, let's add some noise. And we'll make it monochrome. And so this, when you get way in, is going to be either black or white. And there's going to be some grays too. But then we can do that a few more times. There's got to be a way to do like better noise than this, but that's fine. And then I'm going to do that again on a much smaller scale. So we're adding noise there as well, but we made it smaller. So now if I scale this up and layer it over top, we get something. So I can now add this to the other one. Let's subtract it instead. I think that may make more sense. Multiply? No. I had such a great idea. It's not gonna work though. Oh well. That's a lot of stars. Oh well. It looks black and it looks kind of weird. And so all these lines that you're seeing are because we overlaid that other texture on it. And so that other texture, or the smaller one we scaled up, this is the resolution of that. That's why we're getting those lines. But there's got to be a way we can make it better. Better than this. But I don't know how we want to do that. Like we could pull in some actual stars. That might work. Actually, let's do shader random function. So there's this guy. This is going to generate a random number in a shader. And so what we can do is we can make a skybox shader. And what we're going to do is create a surface shader. We're going to call it stars, I guess. And we want to create this function like so. I think it may not like this. Yeah. It wants this to be a float too. And I think that's all we had to change. Did it not save? Oh, it saved. Why is it still giving the same error? Okay, that's weird. We'll save again. Get the same error. Oh, I only changed one of them. That's my problem. Okay. So this is going to take in a 2D array, or a 2D point. And then based on that, it's going to generate a random number, pseudo-random, because it's always going to be the same for those inputs, which is important because now we can use this and actually plug this in. And this should, if we put this in our skybox and call it stars, and then we want to plug in our world normal. I think that's what we want. One sec, I'm gonna look up Unity. Ooh, that's not how you do that. Unity shader variables. This guy. And so we want our shader variables. I went here yesterday and this also didn't give me what I wanted. Surface shader world position. I don't actually want the world position, but this is the easiest way to find it, if I remember. Local position. There's like a world normal or something. Oh well. I think it's fine. We'll make something up. Okay. Undeclared identifier fract. Okay, we can work around that. For now, we're going to create a stars material. And this is going to be our stars. We can throw that in the scene. You can see Unity's doing its whole lighting thing. Let's see, we can get rid of that. What am I doing? I'm getting totally lost. This is wrong, but oh well. We want our... What is this even doing? I don't think we need that. Don't think that's required. Ooh, that's kind of weird. Oh, I know what's happening. We're plugging in the world position of the skybox, which isn't what we want to plug in. And it's giving us random values, which are then being used to draw, which is not right. So what we want is we want to either draw a star or not draw a star. And so get fragment normal. There's some way to do this. Like Unity has a way in surface shaders that it will return the normal. And I always forget how to do it. And it's something obvious. Need to write more shaders. That would solve this problem, but whatever. World pose surface shader. Actually, there's an example in here if I remember. It's right. The world reflection, I think this is what we want. And so if I remember correctly, this is going to get us normal position of that normal. And we should be able to use that, plug it into here. So what we want is we want to plug in two positions. Well, we want to plug in all three, but we want to plug in... I don't know how we'll do it. Float, we'll call it the amplitude of our random float 2 of our inputs world reflection dot x plus the inputs world reflection dot z, and then here we'll do the inputs world reflection dot y and the inputs reflection dot z again. And all we're trying to do is just get something that it will always be unique for each position. And this should get us stars. The problem with this is it's going to get us stars based on the resolution of whatever device you're on, which probably isn't good. And we need this to be a plus. There we go. Ooh, did it not like that? Doesn't appear to have. So let's do that and take in our amplitude. Multiply the color, get all of those. Oops, can't open this item. Yes, no, whatever. Maybe so. And we get nothing. This is cool, isn't it? It's kind of weird that that pink comes in. That's not supposed to happen. I've done this before, but I haven't used a random function for it. I used a noise function. I used not Perlin noise. I used something else. There's the thing that comes after Perlin noise that I should use, but whatever. We'll look up something for what we want. Is we want some way to generate Perlin noise for Unity, and then we can use those inputs to generate. So Perlin noise is going to look like this. Well, not like this. It's going to look like one of these things. And so with that, we should be able to take it and get our stars out of it by taking a few samples from that, and we should get something resembling a map. We're going to spend so much time on these stars. All right. Yeah, I don't like that it goes purple. That's kind of weird. So I'm going to switch this back to like a procedural thing and increase the size of the sun a bit so it just looks scary big. Remove all the atmosphere. Get rid of both of those. So there is no ground and there is no sky tint. And then we can increase the exposure of our sun so it's just scary bright. And now everything looks kind of barren, I guess, but that's fine. And then over top of this, I think we'll probably add something. But we have a player. And we can land on things. Cool. Probably going to be super confusing, but that's fine. Yeah, we'll have to pull in some sort of I guess actually I have some nebula assets that I can pull in. I don't think I'll be able to upload them with the rest of the open source stuff, but we can do that. And that should give us at least some semblance of location. It may not be perfect, but it'll let us find where we are. So, nebula. So let's import this guy and do something with it. This is going to give us a bunch of, it's just a 6-panel skybox of a nebula that this guy made. I don't know. Doesn't matter. I don't know why I say this guy a lot. Who knows? Maybe it's just a robot. Either way, once this is done, we'll plug it in and it should give us something else. And then we can use that instead of what we have. Because the biggest issue I'm seeing with this whole idea is you're just going to get super lost. So we've got this, which kind of fits the theme, but I just want something simple. Got red, got red, stars. This may actually be the easiest. It's just classic stars. But what else? Yeah, let's use this guy. There we go. So we've got some blue, and we should get some lighting on our objects from that, which should help kind of illuminate them. So now we should be able to start. No? Okay. So hopefully this kind of makes it easier to see. I'm gonna get lost. Okay. Yep, gonna totally get lost. Is this not on? Well, one sec. Nope. I grabbed the wrong one. Alright. So I should be able to fly. Oh, it's moving. That is really weird. Okay. Yep. This is gonna be disorienting. Where am I? Down. Okay. Yeah, that rotation might be a bit much, but oh well, we can deal with that later. All right. So that was enlightening and also a little bit scary. It was scary staring off that 50-meter high, just white cube. This is just a whole other level of weird. Yeah. I almost feel like, does it make more sense to just give the player control over their rotation? And so if they want to hit the side of something just sideways, is that good? Do we want to just let that happen? I almost feel like that might be better. Maybe more confusing, but it might be better. Yeah, let's do that. And then we can update this thruster to use this thing as our rotation. And so we can do like, we've got yaw from turning, but then we need like pitch and roll, which I think we can do roll left to right and pitch up and down on this. And hopefully that works. I have no idea. The thing is nobody's really, I haven't seen anybody try this kind of movement in virtual reality before, so I don't really know what works and what doesn't. We're just kind of poking in the dark and hoping people don't get sick. But yeah, it really wasn't that bad. The thing was, it was just really hard to judge when it would happen, and so when you did switch between gravity fields, it felt very sudden. And I think we can smooth that out. We could have smoothed that out quite a bit. We just haven't. All right. What do we want? Stars, world position, none of this stuff works. We want to take our player gravity controller and we're going to remove this rotation. So we're still adding gravity. We're just not adding any of this. And I'm actually gonna write out this target up vector to our object so we can debug it a little bit. And also so other things can use it. And that way we'll have some sort of object-oriented design. All right. Target up vector is out there now. So we want these thrusters to also handle yaw, pitch, and roll. So let's do public float yaw force We'll give that a 10. We don't want yaw actually, because yaw is left to right. Yaw, we'll give it pitch, force, and the roll force. So roll is going to be like spinning your character side to side, and then pitch is going to be up and down. So those are the only two things you really can't do when you're just standing on a floor. So we need to let people actually do that, so they have full 6 degree of freedom movement without ever leaving the standing position, which is probably just going to make people sick, but that's fine. I mean, it works for like descent, right? So how bad can it be? All right, got this. Let's add relative torque. And so this should add a relative force along the X or the Y, or whichever direction we want. Now, I just have to remember how the torque works. I think you give it an axis, but I don't think that's what it wants. So the jetpack controller, we want to take the wheel position dot X and add vector3 dot right. And so this should let us rotate, I think. I'm just going to test this really quick. It will be quick, and if we screw it up, it's going to be weird. Okay, that doesn't really do anything, but that's probably because this is too low. Actually, I don't even think we're referencing that value, so it's going to be a really light push. Times are, this is going to be roll force. Okay, that's not really doing anything anyway. So let's give it a good amount of force, and we still aren't rolling, which is a little bit weird. I would have expected that to do something. Huh. Our play space also isn't rotating. Oh, that's because we took rotation off. That's why that's happening. Okay. I think we want to just let this work. So this player gravity controller, I think we want to just keep this here for now. I think eventually we'll split this part off into its own separate class or something, but for now, I think we'll keep it there. And it honestly wasn't that bad. It was a little bit weird the first time it happened, but then you got used to it. Sort of. I think if you start like slingshotting between a ton of these things, then it'd get really weird, but okay. We are rotating. We have that, all of these. What else do we really need? We need to be able to blow asteroids up. We need them to move and collide and actually have like a play space. And we need like you to lose when you get crushed between two asteroids, or just bit. I mean you can land on them, so the only real problem is if you get hit by two of them, right? I think that's the only issue, is that's the lose condition. Is if there's two asteroids and you get hit by two, then you're done. Or if you blow yourself up by not running away from your bombs. But I don't think anybody's gonna have that happen. Okay. This has to be so weird to watch. Because you're just like sitting there floating. Huh. Yeah. It's either going to be really sweet. Oh, whatever. We'll figure this out. For now, I think we're going to leave exploding them for the end. Because that actually is going to be really, really simple. The hard part is going to be everything else. So let's think. We need to fix how the rotation happens. We want it to be better than it is, and we need to fix gravity as well, because it's only pulling you towards the nearest one you're at near, and we don't really want that to happen. We want it to pull you kind of intelligently, but also like be affected by a few different things. So I don't know how we're gonna do that. Okay. We've got 6 asteroids. Player. We need a way to move them, but we also need a way where they don't... Like, I want them to move, but I don't want them to just like fly off somewhere else. So we almost need something to keep them in place, or in play, I guess. But I don't know what that's going to be. Like, we could have it all rotate around something bigger. Like around, I don't know what. And just kind of have them like move in and out of each other. But all kind of stay around that line. Or we can do something completely different, and I don't know what that'd be. That's a hard question to answer. I guess we also, like, normal asteroids has like waves where they just keep coming in as waves, and you just keep passing levels. I'm not sure we need to do that. I mean, if we have you around like in an asteroid field, for example, we can just keep spawning new ones out of your view, and they'll just keep showing up when you're not looking. And that way, it's just who can get the highest score before something horrible happens. That almost makes more sense. So if we're going to do that, what do we need? We need... Let's make a planet. And we'll put you at 1,000. Well, let's actually look this up. How far from the Earth is the moon? A very long way. So we would need, if it's 384,000 kilometers, that's 384 million units in Unity. And that's a really long render distance. Like, the problem with that is it's going to mean we're going to have a ton of floating point issues right up close to us if we start rendering things that far away. So I don't think we can do that. We may have to fake it. Put it at 1,000. Do that. Blow this up quite a bit. And I guess it doesn't really have to be like Earth or anything like that. It can just be standard planet. That's a fair distance away. And you should still be able to see it, even though it's a little bit tiny. Let's see. Yep, so there's our planet. And we can actually run some sort of shader on that. And that should eventually do that. Well, I'll do the shader in a separate video, probably tomorrow or something. But for now, there's our planet. And what we're going to do is we are going to constantly have something happen. We want asteroids or something to be here. And so, I mean, we've got some of them. Let's make one of these big. And I'm kind of screwing up the geometry of it a little bit, but that's totally fine. Doesn't need to look super convincing. There. That is a big asteroid. So that thing should be a lot easier to land on, for one. We may have to do something with like sound or something. Oh. I also hadn't considered this. Unity got rid of dynamic mesh emitters, which is pretty much how we were intending this whole thing to work. So we can't have non-kinematic mesh colliders, which is what we need. Which means we only get like spheres and capsules and a few other things. So we may have to get kind of creative with how we want to actually collide with things. Because right now, like you just saw, we were floating off in the middle of nowhere. And that's not what we want, because it's the rigid body or the physics collisions are not based off of the actual mesh. They are based off of the physics body. So it's really important that our physics matches up with our mesh, at least for the most part, because if it doesn't, you're gonna get totally lost. So to make it big, I guess we have to do it the old-fashioned way. Do something like that. And that kind of works. Okay. And we're in orbit. That's fun. One thing I'm thinking is we can change this so you only rotate towards the object when there's a certain cutoff distance. I think that may kind of help with this, because right now, like if I want to fly here, from here, it will lock onto here and then there, and that will be very disorienting because it'll start rotating towards one and then our momentum will carry us past it. So we can make this a lot smarter. So I think now is a good time to break this off into its own function. Right, because we've got a target rotation, yeah. So let's get a player, I guess we'll call it that's not right. Player gimbal? It's kind of doing what a gimbal would do, sort of. Okay, bye. All right. That's not what that's not where that goes. That goes here. So this is going to require a, what did we call it? Player gravity controller. It's going to require what we had, and then we're just going to do the lookup on the target up vector. And so all this thing is going to do is it is going to handle rotating our player to look where it needs to look. So we've got our private player gravity controller. We'll call it the gravity controller. And the gravity controller can look, ooh, not like that. Can look at the target up vector, like so. And this should do exactly what it was doing previously. It's just now separate. So we can add some things here. So just to make sure this is working, I'm gonna test it quick. But first we wanna get the component of the player gravity controller, like so. And then we want to attach it to our camera. There we go. Okay, let's see how this works. Well, it's working so far. Okay, so it still works. Kind of launches us into orbit again, but that seems to be a running trend. One thing we may want to do, one thing that was a problem in the last one, was it was really easy to slide on things, like absurdly easy. Like one of my favorite things to do with the last demo I did was just to kind of ski between a bunch of the really tall buildings. It was fun until you ran into one of them and knocked yourself over. But it was actually quite interesting. But the issue is you kind of slide a lot here. So what now? Got our camera way down there. That's rotating to do its thing properly. I think everything is working for the most part. It's rotating, our camera's doing all that. That's good. Everything does what we needed to. So float max distance rotation. So as I'm thinking about this, I'm thinking there's a lot of ways we can rotate. And so I think there's a lot of variables we're going to have to consider. Some of the things is rotation, or not rotation, but like the rigid body's velocity, for example. If we take that, there's going to be a certain velocity that you have to, if you're going above a specific velocity, then trying to stop you probably isn't what we want to do. We probably just want to just let you do your thing in whatever rotation you're on. And then there's also a max distance. So if you're not anywhere near anything, we don't want to bother rotating you. So to do that, max distance limit. We'll set a max distance limit of like 20, I guess. Public float max speed limit. And we'll have to tweak this a bunch, but I'm going to say if you're going under 5 meters per second, the velocity of the rigid body of the player is less than 5 meters per second, then we're going to use that. Then we're not going to apply anything. And we can probably come up with some sort of heuristic or something, some sort of algorithm to calculate, to take these values and actually calculate when we should and when we shouldn't. For now, I'm just going to use 2 clamps. So we're going to require a rigid body, like so. Rigid body. We'll make this a new rigid body, again with Unity's reuse of components. And we'll get that rigid body from here. There we go. So if our rigid body dot velocity's magnitude is less than the max speed limit, and our distance to whatever we're trying to get to, the gravity controller dot something, I don't think we have a way to get the nearest. Yeah, we don't. Public gravity emitter, target gravity emitter. We'll do that. And so we'll set the target gravity emitter here to the nearest one. And now that's exposed, so we can use it here. So our gravity controllers, whoa, what happened there? All sorts of weird stuff. Target gravity emitter dot transform dot position, and we want the difference between that and our current position. We're going to actually use the rigid body center of mass again, and we want to check if that magnitude or the length of that vector is less than the maximum distance. Let's format this a little bit better. There we go. And then we only want to do this if those are correct. So we have a target rotation. That's all that stuff is all happening anyway. But it's only going to happen now if our velocity is below our speed limit and if our magnitude is below the maximum distance. So hopefully it works. So I should be able to just fly straight to this thing. Oh shoot, I missed. Where'd I go? I got lost. Well, the thing is it's harder when we're sitting here to not get lost because I'm not putting on the headset, obviously. Well, we obviously were able to cancel that rotation somewhat. So even though it started, it didn't finish. So I think there's some tweaking that needs to happen, obviously, but it seems to be working, kind of. All right. Our max speed limit, I'll increase that to 10. No, don't get lost. I got lost. Shoot. Okay, one last time. For real this time. No. Okay, so it seems to be working, and then we launched ourselves into orbit, so we're not obviously following anymore. So I'll have to tweak those. I think I'll do it on my own time because it's probably going to take a bit. But it seems to be doing its thing. Kind of. Yeah, I don't know how we want to play with this, but I think that's on the to-do list. Next up, we really just have a few things to do. We have to make the world a little bit more dynamic, and we have to place bombs. And that's about it. So, since we're not using this control pad anymore, we can probably commandeer that for our bomb placement, I guess. So we can just like press this and stick it on the ground, and then it will just arm. I was thinking we could do like some sort of mini game on here, so it will like start completely full, and then you just have to keep, and then it will slowly like decrease a bar inside of there, and you have to keep your finger in there. And so the thinking there is there's going to be a lot of things happening in this game. Even though it's fairly simple, there's going to be like asteroids flying towards you or away from you or whatever. And so you may have to do some other things. So if we can add some extra challenge of trying to like actually arm the bomb, I think it may make it more interesting. I think we'll have to play around with that, I guess. But hopefully we can get some more orientation stuff working. I'm gonna, just so it's a little bit easier, because that side was feeling a little bit empty, so I'm flipping the sides. That's no real reason, just this side has blue and this side had black, so now it's got a planet. What else? Something. Yep, we're gonna do the bomb thing. And so I think how it's gonna work is you're gonna take this, you're gonna activate it, and then you're gonna have to actually physically touch it on the ground, or at least get it relatively close to the ground, probably like within, you're gonna have to really like reach down. And so that's sort of how it's gonna detect it, because otherwise you just press this button and be like, okay, we're done. But I want you to have to do something, and we already have the triggers being used for something. So I think this is probably our next best guess. So that's what we're gonna do. That button is going to become our bomb placement device. So let's actually quickly make something that looks somewhat explosive. It's still not going to, but that's fine. I mean, I guess. Oh, lag. Okay. So we've got a cube. It looks very explodey, doesn't it? We're going to make it a little bit more explodey by adding this guy to our weapons resources, and we're going to call it the mining core. And we're kind of going on with a mining theme here, so that's why we're calling it that. And the idea with this is it's going to, why does it keep adding all of these colliders? This is wrong. Okay. So there's this. Oh. And we want to make it red. Mostly because things that explode are red, right? It's like the classic red barrel. I lost it there. Is that a material for it? Mining core material. Stick that on there, make it red. There. No? No? Okay. So what's happening is Procore is overriding the material, so I have to actually set it this way. So with Procore, you can actually assign materials to different faces separately. So if I only wanted one side to have that red, I could have done that. I just want it all to be red because red's a cool color, I think. All right, so we've got a tiny little red cube. And this thing is going to blow up these platforms. And now, what else do we need? I think that's it. Right? So we obviously need some way to place it, and we need something to detonate it. So to do that, we are going to have our mining core, and that's going to need some new it's going to need something, some sort of weapon. Delayed fuse. So this is going to destroy the object after some amount of time. So after you arm it, its counter is going to count down. So armed equals false. Timer is going to be equal to, say, 5. 5 seconds is enough time to run away, right? That's probably fine. And then we want to subtract the delta time from this if it's armed. And then if the timer is less than 0, we want to destroy it. So that's fairly simple. And all we have to do is find our... Did I delete it? I must have. Oops, I didn't mean to delete it. Why is the material wrong? Whatever. Okay, so there is our mining core. It needs our fuse. There we go. And we can apply that to that. And the only other thing we really need to do is we need to take that, well, we need to attach something onto our camera rig so that these controllers, these jetpack controllers, have something that triggers placing these. And so we want to save public, let's save a boolean of wheel pressed. So if the wheel is pressed is going to be if the device dot get press down touchpad. This is the part where we guess. Sure. I guess there's an easy way to check this. So wheel pressed, that's set. We're using our right controller, which I believe just turned off. So we should see that become true when I press this. Or not. Well, that was fun. Now we need to fix it. Oh, something caused it to start turning more there. Wheel pressed wasn't working. Huh. Get touch, get hair trigger, a few other things. Well, let's try that again. There's only so many to choose from, right? Grip, trigger. So there's a few other buttons that we could use if this ends up not working, but I'm hoping we get it working. We've got the A button. What? I don't even know what that is. There's no A on here. There is the grip. Oh shoot. I hit the wrong thing. Oops. So I hit the menu button, which does the Steam menu. Okay, so I think we can, oops, safely assume it is not the A button. If only somebody had read the instructions. Oh well. Application menu, that's what I just hit. The D-pad. Dashboard, max, touchpad. It seems like the touchpad is what we want, right? Get touch down. Maybe we're supposed to be using this. I don't know if they have an example of this. I haven't really looked. Just kind of fooling around and testing things. So it's obviously this controller. You can see it move. The wheel position and stuff is moving. But it doesn't appear to be doing the buttons that I'm anticipating it should do. So now what? Actually, what if you would just have it be the grip? So you just squeeze your controller, put it down, and release. So it's almost like you're grabbing something. That almost makes more sense. And that way we can just ignore this wheel entirely. So the trigger makes you go faster, and then you just grab it, put it down. I think that makes sense. Let's do that. And I'm not just doing that because I don't know I don't know how to fix this problem. I actually do think that'll be better. And we can figure things out better this way. I don't think this is gonna work. Yeah. Okay. We're getting null pointer exceptions too. I should be looking at that. Why are we getting null pointer exceptions? That's a good question. Well, right, because our target gravity emitter can be null. So this gravity emitter is not null. Okay, so that should solve that. And that would have only happened on the first frame, I think. But either way, oh, okay. So that's normal, all those null pointers and stuff. And that's just because Unity recompiled the scripts and I had changed things, so it had lost a bunch of the references and had tried to keep going, but couldn't really keep going. Okay, so the grip still doesn't work, and that's because we're doing a touch check and not a down press. Git press down, sure. Now hopefully this works. No? Okay, fine. Well, we tried. It seems like it's the same issue, and I'm guessing that may fix it. Because I'm wondering, yeah. So what I'm assuming is happening is that git press down fires for a single event, or for a single frame. And it's only the frame that it was initially pressed on. And so we want to just know if it's held like this. And that's probably what was happening with our wheel as well. So if I go here to our wheel pressed, we can just plug in the wheel quick. Wheel, where's the wheel? None of these are wheels. Did I miss it? There it is, touchpad. Okay, and now it should, we should actually see it working. And it does. So that was what was going on. So let it be known that if you need to detect if something is held down, use this git press instead. We're going to use the grip. So that was irrelevant, whatever. We'll call this hold bomb. Sure. My naming gets so bad when I do this, but that's fine. So if you're holding the bomb, then we're gonna need something to actually do something with that. And actually, I think this is probably going to be a bad idea, but I don't think we're going to have... I'm going to make this mining core, is what we're calling it. A rigid body. I'm going to make it not use gravity, but I am going to give it the gravity controller. And so theoretically, if I did this right, this thing should be pulled towards whatever. And then the idea is we're going to make it so you can throw it. So you won't necessarily have to land to use it. And the cool thing is it actually acts exactly like our player does. So it connects to this as well. So only issue with that is we appear to have hit our asteroid with some force, and now it is falling slowly, but it is actually falling. So, oops. Well, that's actually kind of interesting that, like, if we run into one of these at high speed, it's not just going to stop us. It's going to actually physically react to it, so it's actually going to move with us. So that's kind of interesting. Cool. So now, let's make it so we can actually throw these things. And then, I think that's it. Yeah. So we can base that off of Valve's like throwing demo, which is somewhere that I'm not remembering, but that's fine. we want to get into weapons. Throwing weapon controller. And so this is going to take a bunch of stuff. I'm going to actually try to open up the sample from Valve's demo, because it actually does come with being able to throw stuff. This guy, throw it over here. And so all it does is it takes a prefab and an attach point, and then it creates a joint around it and just attaches that object to it, and then just releases it when you throw. So we can actually take all of this, and then we'll just touch it up and make it less gross. So I'm also going to attach to our jetpack controller. And so this is where our information is going to come from, we're not going to do anything with the devices itself. So we don't need this tracked object at all. And we can just do our controller dot has bomb. No, that's not what we called it. We called it like hold bomb. Something bad. Nope, we didn't call it that. Alright, let's close that and reopen it because Visual Studio is being weird again. It is continuing to be weird. We're not getting any IntelliSense at all from this, which is annoying. I think that's the word I want to use. Okay, so we're going to use, this is correct, even though it's saying it isn't. Else if not controller hold bomb. Then this should work. Then we want to add our component fixed joint. That's doing all of that. We don't need any of. So we destroy the joint immediately. And the joint is what's going to actually hold it to the controller. So it's going to kind of just like hang there. And then they're attaching something that's going to destroy it after 15 seconds. I'm not going to do that. I'm going to grab the component from it. Specifically, we're going to grab the delayed fuse component from it. So we're going to call this the fuse, and we are going to arm that fuse. So we're going to set that to true, and then everything else should stay the same. Then they're talking about adding an offset here. We don't need to worry about that. And then all they do is they get the rigid body from it. And then they set the velocity and angular velocity equal to the velocity of the controller. So when you throw it, it actually throws. So I think that's good. I think that's all we need. All we need to do now is actually attach these things. Like so. And it's saying there's a ton of it is having trouble finding all of the like tracked objects and stuff like that. And the reason that is because we deleted that. So do we need that? We might. Yeah, let's add that back. As much as I kind of don't want that, it's probably a better idea to use the actual information we're getting from the controller instead of coming up with our own, because our own is probably going to have a bunch of weird stuff going on that we're going to have to deal with that I don't want to. So does that make you happy? It should. The only other thing is this device is not going to be set. If the origin is not null, then do that. Okay. That makes sense. We can do that. So we'll only use this device for setting the velocities of our object. That's the only time it's ever going to be used. Let it compile. It looks good. Should pull in a few things here. So I can assign those out. And we're actually going to be able to throw quite a few of these right now. I'll probably have to go through and do a bunch of balancing on this later, but that's fine. Tip, attach. I'm going to add a kinematic rigid body to this tip. Like that. And it doesn't matter about like the mass and stuff because it's not really, it might matter a little bit because it's going to be factored into the full mass of this object, which is going to affect how much we actually weigh when we run into things. But for now, we're not going to worry about it. And so we're going to do that on the other side as well. Apply those settings and then attach those rigid bodies to our component. Apply that, and we should be able to throw things now. That's not how you throw things. That's how you throw things. So if I hadn't blasted off, this would have been easier to demonstrate. So we're going to restart quick. So we've got this. And part of the issue that we're running into, the reason I'm flying away right now, is not because of what anything I did. It's because our cube is a physical body, and so is our player. And I pulled them into one another. And because we did that, it kind of broke everything. So we're going to fix that. And the way we're going to fix that is we're going to use some layers. Specifically, we are going to ignore raycast on our mining core. And then we're going to add a layer for the player. And what we're going to do is we're going to change the project settings and the physics. So the player and ignore raycast do not hit. And the reason I stuck it in the ignore raycast is so that our player, or so that they aren't hit by a raycast when we're using them for raycasting. So it's an easy way to avoid, because otherwise we'd be casting rays from our player to our gravity centers, and those things could be hit by the rays. And if they are, then our calculation is wrong and we may rotate towards the wrong thing or other weird stuff. So now I should be able to pull this in kind of close and can kind of shove it into our face a little bit, and it's fine. There's that. Hit the side of that, so it should start rotating a little bit more. We should see it disappear shortly. Huh. That wasn't what I expected. Huh. Oh, well, there's part of the problem. Our fuse did not delete the object like we had intended. It only deleted itself, which honestly, at the time of writing it, I kind of thought that was what I wanted, but it's not. So now we have this. Actually, this still isn't going to work because our mining core doesn't have a rigid body attached. Why not? I'm missing something. Why doesn't I added a rigid body to this, didn't I? If I didn't, I'll do that now. So it definitely needs a rigid body, and it definitely doesn't want to use gravity. And it definitely is going to want our player gravity controller so that it will actually hit. So it will obey the gravity of this game instead of the gravity of Unity. So hopefully now we can drop that thing and we should see it. Yep. After 5 seconds, it kind of disappears. It's kind of hard to throw things. They don't really throw. 1 sec. Nope, they don't really throw at all. Okay. We'll have to figure something out there. I don't know why they're not. Unless fixed joint. Yeah, I don't know why it's suddenly so hard to throw them. Like, I don't anticipate people throwing them that often because I don't think it's very effective. But I want people to be able to throw them. Mostly because it'll be awesome if you can do it well. Let's see. I think part of the issue we're running into is just gravity. Because it's not factoring in the mass of our bombs when we calculate gravity. And so when I reduce the mass, they just had less mass. So actually, we can fix that by increasing their mass. This is going to be a mistake as well. This isn't by any means right, but it's just gonna change how the things work because they're going to be affected by the gravity less. And also, if I slam them down, we can definitely affect the rotation of an asteroid just by hitting it with one of these things. Let's see if I can... No. That might work. And it exploded before it got close enough. Oh well. Point is they're heavy, which means they aren't affected by gravity as much, which isn't how gravity works, but it's how our gravity is working right now. So let's multiply this by our rigid body dot mass. So now I can actually 9.8. I'm going to revert that to 9.8, and the reason I'm doing that is because I'm going to increase our player's mass by 210. So they should have the same effect, but they should actually weigh a bit more. And then our bombs, wherever they were, here, we're gonna increase its mass to like 0.5. We'll have to test this some more. Well, I'll have to test this some more. You guys don't have to do anything. You just have to Wait for games. Anyway, oops. Let's see if I can actually hit this. So I'm going to increase the timer on it so we can actually try. I think that should work. We should be able to hit it, and it should bounce off, or it should attach with gravity. Well, that one hit it, but it appears to have just bounced off. So if I drop one, it's not really affected by gravity at all. It's affected by gravity so little that it's just flying off into the sky. So let's make it weigh a little bit more. Like, it can't be affected so much that you can't throw it out of the gravity field, out of the gravity well of the object. But it also can't be affected so little that it just hangs there. Like that seemed almost correct. Like, I'm kind of happy with that. And it's kind of interesting for it to just kind of sit there and rock. All right. So I think what's going to happen is I think we'll take a bit of a break for now. And I'm going to actually play around with this with the headset on and see how it actually plays. And then based on that, there's probably going to be some other stuff that we'll have to do. I don't know what it's going to be, but depending on that, I'll definitely be back tomorrow, but I may be back later tonight after some dinner and stuff. And then we can make this even more interesting. There's obviously, you can't destroy these things yet. And there's no world, there's no limits, there's no anything. I mean, we have a planet over there, but the planet's boring. And we have a nebula, but the nebula's kind of, there's nothing happening here. And the world is not doing anything either. Like, these don't collide, and the world doesn't have bounds. So we need to figure out a way to do that. So that's next on the thing. But until then, I will see you guys probably later tonight. So till then, see you, internet.